and manufacturers with an in-depth look at the current and future state of housing. His passion for educating lies in knowing how vital the building industry is. Building healthy, safe, durable, and efficient homes has an effect on the buyer, the builder, the economy, and the planet. So Mark's currently leading the Hayward Lumber sales team to provide training and industry support throughout the Hayward Lumber location. So I'll turn it over to Mark.
Thank you very much, Paul. Thank you, everybody, for allowing us to just partner along and sponsor such an important and critical nature of this industry and where it's moving. I've been in this industry now for 37 years, teaching building science, and you can only imagine how long I've been hoping for the speed at which this seems to be progressing. I studied with under Ed Masria's passive solar book back in 1984. So it's a great progression to see that by 2030, we've got this thing licked, and it was his idea. I watched Ed speak several times. So Hayward Lumber has been in business for over 102 years. And we just want to let you know we have 7 markets in California, in the western region of the state. And we have 2 divisions of a company called Small Planet, which is focused on electrification for housing, from carbon dioxide operated water heating to options for improved air tightness in buildings and indoor air quality, which we believe is a fundamental component to how we really look at decarbonized buildings, mean that they have to be incredibly efficient. So Hayward would like to thank everybody for letting us participate in that. I think some of you may know Bill Hayward, CEO of Hayward. He is the previous 5-year chairman of the board of directors of the FSC and Sustainable Lumber Initiatives, and the current CEO of Hayward Healthy Home, which is a goal towards building high performance and healthier buildings and looking at air quality as a fundamental. He also created a program called Hayward Score, which surveyed 80,000 American homes for health and safety. And so all of the goals that we have within the company are to drive towards a better environment. And finally, we just have been investing, as Paul introduced me, in building science. Hayward would like to bring my skills and knowledge. I currently live in Arizona and travel here almost every week to really look at how we improve the complex built environment and improve its overall performance to be durable, safe, healthy, efficient. At the same time, it supports healthy indoor environments. And so we have the expertise here at Hayward to help any of you who are looking towards putting some of these features in play. And we have a long-term commitment to sustainability and helping to decarbonize as best we can in all electrification. So thank you all for letting us support it. We appreciate the support that everybody's given with Hayward Lumber, and we look forward to helping you in any way we can. Thank you.
Yeah, Bill Hayward and Hayward Lumber have been a great ally of Santa Barbara's AIA and really supportive of our efforts to have parades of green buildings and other events like that. So definitely integral part of the supply chain to allow us to do what we've been doing. So I'd like to introduce today's speakers. Both of them are from Integral Group, which was founded in 2008 by a friend of mine, Kevin Hides. Usually you'll see him at Greenbuild wearing a kilt at many of the social events. He's a colorful character, and he has inspired a lot of people to join this multi-continental firm that's really on the cutting edge of designing the best, most sustainable buildings in the world. It's really an incredible company operating in Australia, the USA, Europe, and Canada. They have multiple offices all over the place, collaborating and innovating on projects all over the place, basically. You look at their website, all the services they provide, from mechanical, electrical, plumbing, fire engineering, fire protection, commissioning, lead performance, advanced energy services, climate resilience policy. It's everywhere and everything, it seems like, and really they have attracted the most talented people who are interested in this sustainability effort from all over the world. We're lucky to have Kanika Sharma and Kalina Ferraro to join us today to share some of their knowledge with us. Kanika Sharma is in the LA office. She's a sustainability associate. She successfully pursued and achieved ambitious sustainability certification goals for building projects by leveraging her diverse skills in architecture, energy analysis, graphic design, and data analytics. Her solution-oriented approach and attention to detail, coupled with her breadth of experience enable her to maximize the performance and sustainability of each of her projects. And we have Kalina Ferraro from the San Diego office. She's a principal with Integral. And the office leader down there providing high performance MEP design services for our clients. She takes a holistic approach to design, striving to create healthy, enjoyable, and environmentally responsible spaces while minimizing the size and complexity of the mechanical systems. She's a recipient of Consulting Specifying Engineer Magazine's 40 Under 40 Award in 2015 and Plumbing and Mechanical Engineer Magazine's Mechanical Engineer of the Year Award in 2018. He's a registered professional engineer, a lead accredited professional, and a well-accredited professional. So I'd like to welcome Kanika and Kalina to proceed with your presentation. And what we'll do is we're going to try to get out of here at 1 o'clock. If you have questions for the speakers, put them in the chat. And at the end of the presentation around 12:50, we'll go to questions. I'll try to consolidate them and forward them to Kanika and Kalina for answers. Thank you.
Thank you so much, Paul. So I'm going to share my screen and kick us off. So hi, everyone. Welcome to our presentation. We are going to be talking about decarbonization, which is the hottest topic on the market, much needed. And we're going to be talking about how the industry and companies like Integral are moving towards their thinking from the high performance bridging aspects to now looking at holistic decarbonization, including embodied carbon that Paul also alluded to. And Paul already gave such a great introduction for Kalina and me, and the sustainability lead for our Southern California offices, and Kalina is the managing principal for our San Diego office and a leader in MEP design throughout our firm. And our agenda for today, so we're going to be covering why decarbonization first and foremost. How is this move going to help us to achieve our goals of meeting the 1.5 degree target as specified by IPCC? We are going to be talking about net zero energy, just so we are all on the same page around that, and then how the move to net zero carbon has to happen and what are the different steps that we are currently taking, and hopefully bring along in this journey, all of the things that you all can include in your current day-to-day practice, and finish with some case studies of how we've started to do that. And then quickly just go over what's next for the industry and where do we see more opportunities for us to do research and innovation in the field of decarbonization. I want to start off with a quick land acknowledgement. So we have instituted this practice in all of our external presentations at Integral, where we want to acknowledge our ancestors and acknowledge the care that they have shown for the land that we currently sit on. So I sit on the Tonga and Chumash people land. They were the original inhabitants and caretakers of LA. And Kalina is in San Diego, which is the unceded ancestral land of the Kumeyaay people. And this is a small gesture that we do, and we understand that there is a long way to go to get reconciliation and reparations for these people, but we have to start with land acknowledgement. So that's something that we encourage you all to institute as a practice in your presentations as well. So again, Paul gave such a great introduction for our firm. We are a global network of engineers and consultants located around 21 offices around the world. We work collaboratively between all offices on multiple different projects and have a staff of over 600 people who are deeply, deeply passionate about engineering. And we like to call ourselves deep green engineers and consultants. So excited to be presenting and sharing the work that we've done with all of you. Some of the accolades that we have achieved, we are well known for our work in the zero energy field and now quickly moving to zero carbon. We have over 100 zero energy projects, more than any other MEP firm, and then also have been the recipient of 22 plus AIA Coach top 10 awards. So starting with why decarbonization. So Paul mentioned Ed Mazdria, and this is a slide that I've taken from one of his presentations where he talks a lot about carbon budgets and how much is what the pathway should look like if we are to meet the IPCC goal of 1.5 degrees. And this is the trajectory that we are currently at, where if we are to get to our target, we need to drastically start to reduce emissions by 2030, 65% emissions reduction by 2030, and then complete phase out by 2040. So that's the goal that we aspire to. Our current trajectory doesn't really come close to where we want to be. And so with the hope is that with all the work that's happening and the drive, the demand that's driving all of this work, we will be able to get on this path pretty quickly in the next, now we are almost in 2022, 8 years or so, and get to that target to meet the 1.5 degree challenge. That is a huge challenge for us. And I'm sure this is not news to you all. We are all building professionals here. 40% of those emissions that we have to mitigate come from the building industry, the work that you and I do. And so focusing on building operations, and rightly so, that is what has been happening in the last decade or so, focused heavily on high performance design, has been to address specifically the building operation emissions. And while that work needs to continue to grow, we also need to be focusing on the other part, which is the building materials and constructions, the embodied carbon, and the overall decarbonization of our built environment. So this is where net zero carbon buildings come into play. And these are no longer a pipe dream. We are already seeing many firms, many companies get on the bandwagon, trying to implement strategies and commitments from leaders around the world to decarbonize not just the buildings, but also the grid and the infrastructure. So looking at it throughout the different sectors that we work in. And in the building industry specifically, we are seeing a lot more movement in the climate policies and the regional and local policies around climate change, resiliency, even equity, and factoring all of that in to kind of drive that demand for us to get to our goal. And just within the last 5 years or so, we are seeing a lot more of these. So these are just some of the policies that I've put on the screen up here, but there are so many more that are in the works, especially like as the infrastructure bill just passed, there will be so much more to come. And so we have to be at the forefront of addressing these and making sure that when we think about our future projects, we are taking into account decarbonization, social equity, equal access to resources, renewable energy resiliency, all encompassing in our design and operation. And the state of California is also doing so much more, and we are already seeing these electrification reach code adoptions. And I know Santa Barbara is one of those cities that have adopted one of these, and we have over 50 cities that have already pledged to phasing out gas or in new buildings, and also phasing out any new gas in the future building infrastructure. And just last week, the city of Solana Beach actually passed this as well. So there is a lot more movement that's happening here, and we are anticipating this to just continue on forward with so much advocacy that's happening at the state and the city level. And it's not only just focused on operational carbon now, there is so much demand around addressing embodied carbon with the Buy Clean California Act that was passed, the latest one, Buy Clean Colorado. We have LECLA from New York and New Jersey, and so many other certifications that are really driving the companies and the organizations to think about these things holistically. And for us too, in addition to these regulatory policies, we are seeing a lot more movement from our clients. The people that we work for, they are continually committing to these carbon neutrality initiatives and pledges. And so all of this just makes us even more encouraged and hopeful that there is change coming, and we are a part of that change. So moving on to the more technical things, I'm going to pass it on to Kalina, and then I'll come back to talk about embodied carbon.
Sure, thanks, Kanika. So with that stage kind of set about the need for an urgency to address climate change and really do a better job of what we do with our built environment, a lot of the focus and conversation on that performance over the last 10 to 15 years has really set the standard at trying to achieve a net zero energy building. And that's really been our focus. And if we go to the next slide, when we're talking about net zero energy, it's looking at making that building, taking all of the energy use in that building, the lighting, the equipment, the different HVAC systems, hot water, over your entire building area, figuring out your EUI, and then offsetting that with on-site renewables. And we say, okay, well, as long as the total amount that we use balances with the total amount that we generate over the course of the entire year, we'll say it comes out as a wash, and that's how we get a zero net energy building. And that's that has been a very high performance goal in the past. And it's really based on this notion that the grid was generating that electricity or our other heating sources were all coming from fossil fuel based systems. So it was taking a perspective of there being a consistent carbon based source and trying to offset that source with on-site renewables. And so when we were pursuing these high performance designs, we would find a pathway to get to this level of performance. And we'd look at optimizing different strategies to first reduce on-site use overall so that we didn't have to use those energy sources through passive strategies or efficient systems or reduction of loads. And then ultimately we'd offset that so that we could say, well, we're not going to use the grid on balance, that will generate enough on-site to offset that. What we didn't really pay attention to in the past was when that energy was being used. Because again, this was based on a paradigm of the grid being fossil fuel based. And so it was always a carbon based source if we were pulling from the grid. Now, the problem with that is that the paradigm has shifted. So rather than having a grid that is a single source, carbon intensive grid that's the same all the time, we actually have a much more multifaceted grid now. And that grid's continuing to change as we go. So if you want to go to the next slide, we can see that while we've got our buildings, which are using the energy, we can't just treat it as a single source carbon intense grid coming in anymore that we're always trying to get off of, because that grid's now evolving to become more complex and have a lot other sources associated with that. So especially here in California and in Southern California, we do have a lot of renewables on the grid. We see more utility scale storage coming on. In other areas of the country, they have large scale hydro and nuclear that are also providing carbon-free sources, depending on who you ask, for different electricity. And so we can't just treat the grid as a uniform source from a carbon intensity standpoint. We really need to sort of pull back the cover and have a bit more of an analytical approach to what the grid source energy is from a carbon standpoint. And so as an example, if we look at the energy use over the day here in California, we can see that over a typical summer day, the source of that energy is coming from a variety of different pathways. So we're importing energy. We still have a large portion of gas. That's that red bar in the middle. And then you can see that the renewables increase quite significantly over the course of the day, which makes sense given the amount of solar we have. So our wind energy is pretty consistent throughout the entire day. So you can see even overnight, we have a strong source of renewables. And then during the day when our solar kicks in, that really picks up. And so the amount of carbon associated with the energy that we use changes depending upon what the source is and what time of day it's being used in. And so in particular, that you can see that there's areas of the day when, towards the end of the day, you can see as that blue portion gets smaller, the gas portion has to get bigger to make up for that. And so we look really critically at these times of the day where we have a high percentage of what we call marginal emissions. And so what that means is that when we have a certain mix on the grid, we might be meeting that certain baseload requirement, but because those renewables are tapped out, adding even a small amount to that demand means we need to kick on a whole new plant. So these are what often get referred to as peaker plants. And so we can get significantly more emissions if we're using energy from the grid at those peak times that would require additional fossil fuel plants to be brought online. And so really thinking about the building peak loads and when we use that energy, rather than just thinking of it as average or net energy over the course of the year, is becoming really, really important from a carbon standpoint, because the grid is actually not so bad if we can use it at times when the source is primarily renewable. And we know that over the next couple of decades, that percentage of renewable source will continue to grow. And so having our buildings work to optimize with that grid mix is going to become an increasingly important design decision, rather than just focusing purely on our on-site and trying to offset on a net annual basis. So from an operational standpoint, that's how we have to shift our thinking. However, from an overall carbon standpoint, we need to look, as Kanika had mentioned, beyond just this operational value and make sure that we're looking at the other pieces to do with carbon as well. So this shift from thinking energy only to thinking carbon. And Kanika, I'll let you sort of fill in a bit more on the whole life side of it.
Okay, thanks, Kalina. So yeah, exactly. So focusing, like as we move towards this whole life carbon thinking, we have to not only address the operational carbon, but also the embodied carbon, which constitutes well over 10% of our overall global emissions. And what that means is looking at each and every stage of our material procurement process. So what kind of materials are we selecting? Where are they coming from? What's the impact of the transportation, manufacturing, going on to like, what would that look like at the end of life of that built asset that we are currently designing? And so this kind of summarizes what all of that, would look like in the best case scenario, where we are addressing the operational carbon emissions, the embodied carbon emissions, and then the most critical piece is like, what are the emissions associated with the reuse, recovery, and recycling of these products at the end of their useful life. And when we look at this whole life carbon thinking over the life of the 6th year of the building, we can see that upfront carbon, embodied carbon emissions definitely are the key, but also there are all of these significant carbon emissions associated with the replacement and maintenance of the built assets. And currently we have, and these are still early days for our embodied carbon assessment, and we are primarily thinking about structural enclosure and interiors, and rightly so. But our firm is also now heavily involved in doing research and putting together technical resources on how to address the MEP and refrigerant emissions, so the associated greenhouse gas emissions associated with building services, all our lighting and mechanical systems that go in the building, and refrigerants that as we start to electrify all of our buildings, we'll start to use more and more of. So thinking about these, again, like from a holistic perspective, is the way forward. And even though there aren't that many resources available currently in the market, we will start to see more and more of these, coming online, and we have to incorporate this into the process in which we design our buildings.
So that's sort of how we've been thinking about high performance over the last decade or so, and some of the shifts in mindset that we need to do to think of that. We've also sort of painted the picture of what the critical nature of this issue is. So what are some of these solutions? How do we need to think about our designs going forward to continue striving for high performance, both in operations and also in the construction and the embodied carbon aspects? So we'll give you a few key sort of items to think about and some strategies to focus on moving forward. So one of the items is shifting our perspective from a relative energy reduction to an absolute usage. And so one of the issues with a percent savings approach is that it really depends on what your baseline notional building is. So you lose the advantage of smart layout of footprint, of a lot of your window to wall ratio, of using a smaller building if you can use less space. All of those benefits and those really kind of core fundamental design decisions, we don't see the benefit to those in our designs if our baseline building sees all of those benefits as well. So if we can establish from our building type and our usage and programming what we need and really drive our absolute energy use intensity on that building down per year to some fixed baselines based on those usage and locations, it's a much more real and tangible metric to use to be able to compare and benchmark against other buildings. It's also much more agnostic about the energy, right? This is absolute energy use per year. We're not taking a percentage, we're not taking credits or benefits from one fuel source over another. We're saying, let's make it all one baseline and let's make it absolute so that it eliminates a lot of these loopholes and some of like the tricks of the trade that energy modeling sometimes hid in the performance of actual buildings. So gravitating more towards absolute metrics and absolute benchmarks so that we have real comparisons and we're driving towards hard design numbers to keep pushing that curve down in our usage. So the next one is, again, keeping this focus on, pursuing a net zero approach, but thinking of it more as zero carbon instead of zero energy. So, all of the design approaches that we've been thinking and learning and applying for zero energy, they still apply. This is just in addition to that, thinking about not just an absolute annual energy use, but also thinking about when that gets used in the course of the year and when your renewables can be used at the same time. And so if we can start shifting when those loads occur, start being able to store those renewables and use them potentially at different times, when the grid is less, when the grid has fewer renewables on those, we're going to start seeing that balance. And what we refer to this as grid harmonization, so that we can have our buildings interact more with the grid, so that we're operating more towards zero carbon rather than just focusing on energy. In order to do that, if you want to go on the next slide, we really need to focus on electrification, right? So as long as we're burning gas in our buildings, there is no offset for that, right? It's not as though you can store that and use it later. As soon as you burn that gas, the carbon is in the air. So really getting ourselves off of combustion sources for our space heating, our water heating, even commercial cooking. We've seen significant growth in technology in the induction cooking. And then sort of moving on, even our backup power sources, a lot of those are still generator based. And there's a lot of codes that still need to catch up, but as battery technology continues to develop and become more cost effective, I think we'll see that start to shift. And then looking at alternatives for things like dryers and fireplaces, a lot of the heat pump technology that used to be kind of high end, used to be on the edges, it's becoming more commonplace, more proven, and more cost effective to incorporate in more common projects. So electrification as a big trend in buildings, I think we saw from those REACH codes, it's not just aspirational at this time. We do have codes in a lot of places that are actually going to start forcing this market. And so for the sake of not creating new buildings that are going to be outdated by the time they're constructed, I think we need to, for the sake of our clients, be thinking about electrification, because that's the direction the industry is moving. So next slide, please. And then so we talked about, again, this grid harmonization concept. So not just thinking of energy on its own and not thinking of your buildings as their own islands and thinking of them independently with their own on-site resources, really looking at the grid and when we're using energy from that. The screenshots I have on there now are from a site called Watt Time, which essentially looks at all the different electrical grids through the country and the balance of sources that they're getting that electricity from, and color codes it with the carbon intensity. And so even over the course of a few hours in a single morning, you can see sort of very, very early in the morning, essentially overnight, it's pretty much still a fossil fuel based system. And then you can see as the wind picks up in the Midwest, that goes green. And then later in the day, the solar kicks on out here in California, and you can see it coming green here. And really having systems that can react to that grid, both with what it's doing now, but also understanding that this grid is going to continue to evolve over the next few decades, so that we build in that sort of flexibility and resiliency in our buildings. Is beneficial not only from a carbon standpoint, but we can also optimize that for cost for our clients too. So if you want to go to the next slide. If we have some sort of adaptability in our buildings, we can help optimize that to harmonize with the grid. We can help build in some resiliency if you have that on-site storage in case we have disruptions to our grid. We can also help optimize for cost. What we're seeing is a significant spike in demand costs and critical events. So when the grid is really, really stressed, the utility companies are charging more for that. So even, from an economic standpoint, in addition to the carbon benefits, having this grid harmonization approach and having some on-site storage or adaptability of those buildings really provides a lot of different benefits to the clients and to the site. So moving forward, if we think about a grid optimal design, it's having systems that can respond. So whether that's reducing demand and a demand response option, which may reduce some lighting, adjust set points, some load shedding, plug management, automating this so that it can react and interact with the grid. That's one approach. And then also having on-site storage so that we can just shift those peaks. So if we have our own on-site renewables, having battery technology that's able to store that, or alternatively having thermal storage, since the cooling and heating loads are such a significant portion of the building energy use, being able to have thermal storage tanks in the form of ice or water, or even the thermal mass of the building allows us to shift those loads to a time when it's not going to be at the peak use of the grid and really control the timing of when that energy is used rather than just focusing on the fact that it's used. Next slide, please. So going forward, instead of just thinking about zero energy and just looking at the BTUs or the kilowatt hours used, we're going to have to start thinking of things from a carbon perspective, from a cost perspective, from a time of use perspective, and factor in all of those different perspectives into our design so that we're looking at the building as part of an overall grid, and all of the different sources of energy that we can be drawing from, and also when we use that energy. So that's from a operational carbon standpoint. Really, what we need to do is, again, stick to the basics. All of these principles that we've always done as far as optimizing our efficiency, those all still matter. Optimize your passive strategies, optimize your envelope, efficient mechanical systems, but do it in a way that we're using absolute metrics so that we can compare and we can benchmark our buildings and we can set firm targets. Moving towards electrification of buildings, getting ourselves off fossil fuels, so that as the grid continues to electrify, this building can work with that and we can move overall to a decarbonized infrastructure system, and be able to react and interact with that grid over time, and then provide those on-site storage options, whether that's batteries or thermal, that allow us to have that flexibility and change when we have to use that energy so that we can really be optimizing for those renewables and the low carbon intensity sources. So from an operational standpoint, that's more the mindset we need to be shifting towards. Kanika, I think you have some suggestions and recommendations on the embodied carbon side.
Yeah, great. Thanks, Karina. So we cannot get to that decarbonized future that we all are working towards if we do not address embodied carbon. So embodied carbon is the footprint of the material or a product that, or a system that goes into our built asset. And this, so like operational energy and carbon, like you have the absolute metric of EUI, and we need to measure the more commonly known metric for measuring our embodied carbon emissions is the global warming potential, which is kilogram CO2 equivalent. And the most widely accepted method of calculating and assessing this is LCA. So what we've started doing in most of our projects is doing this kind of a life cycle assessment analysis upfront, starting in the SD phase, doing a high-level LCA assessment, focusing on those high embodied carbon materials and products, and then starting to figure out what those strategies should be to first address that piece. And then as we move towards like the design development, construction drawing phase, then we start to add in another layer of interior finishes, mechanical systems, and all of the other components that also contribute to it. So this is just a quick snapshot of what that typical LCA process looks like. The way that it is calculated is based on the different stages of the life of the building. So like you have the product stage, which is where the upfront carbon emissions are mostly, you have the product shipping in from multiple regions, getting to the site. So what are all of the emissions associated with that? Raw material extraction, transportation, and the manufacturing. Then you get to the construction phase where you have those materials transported from the manufacturing facility to the actual construction site. And then all of the construction installation processes, like the amount of fuel that needs to go in your chains, or any equipment that is operated on site. And then the critical piece is the use stage. So the default way of looking at the number of years is usually 60 years, that we design our buildings for 60 to 70 years right now. And based off of that, there needs to be accounted for any emissions that's associated with any interior refresh that happens. If there is an equipment replacement that needs to happen, any new added material that needs to be installed. And then here is the stage where we also factor in all of that operational energy and the carbon emissions associated with that, especially like what Kalina mentioned, as the grid has started to become cleaner, like we will start to see these emissions lessening more and more, whereas the embodied carbon emissions associated with the materials will start to show a big increase. And then, of course, the end of life, which now we have to start considering as well, is like not designing our buildings for demolition, but how do we design our buildings for deconstruction? So how can we start to design already the systems that are put in place so that they can be reused and recycled at the end of the life of the building? So this is just a quick study that we are done for a client up in the Bay Area, where we were looking at this huge campus project, a new construction project, and upfront the goals, the embodied carbon goals and the decarbonization goals of the project were established. And we did during the SC phase, again, like a high level study, considering what the whole life building life cycle assessment emissions would look like over 100 years. So not designing this building to last 60 years, but for it to last at least 100 years. And we analyzed 3 different case scenarios: the good, better, best. So good, what is available in the market; better, where we aspire to be in the next 5 years; and best, what is that absolute best that we can achieve by selecting the most low carbon products that will be shortly coming online in the market. And then in addition to just looking at the buildings and materials, we looked at it through the lens of eventually construction, what is the travel emissions associated with the design and construction teams, anything associated with the refrigerant decommissioning, employee commute, and also the work from home shift. So this was like an all-encompassing study that we did. And here on the pie chart, you can see that embodied carbon does make up at least 50%, if not more, of the carbon emissions associated with the life of the building in 100 years. So this was a big study for us to kind of start to quantify some of these and annualize some of these metrics so that we can start to use this on other projects and the lessons learned to basically get to the scenario, which is we need to start to offset all of the emissions associated with those different stages with the emissions that we can, offset using carbon sequestration methods, or also purchasing offsets for new renewable systems coming online. And how do we get to that positive carbon state? So that's like one level up after decarbonization. And in most projects, we see that the biggest culprits are concrete, steel, aluminum, insulation. These are the big ones that we can already know without even doing the analysis that we have to address them. And that's why there is this huge advocacy effort currently happening at the AIA California level, the USGBC LA level, to push for concrete to be included in the Buy Clean California mandate. So as we can incentivize the concrete suppliers and the manufacturers to start generating the transparent environmental project declarations for us to do that kind of analysis for all of our projects. And then for the interior products, carpet tiles, raised access flooring, because of all of the structure that goes under that, suspended acoustic ceiling systems, drywall, and glazed doors are a huge component. And now more and more we are seeing that MEP can even account for 30 to 40% of the embodied carbon in a TI project. So considering all of these is a must when we start to look at these steps to reduce embodied carbon of our building materials. So in the next few slides, we just have a quick cheat sheet put together. So we, just like operational energy, like, we put the traditional pathway to performance, we are still trying to figure that out for embodied carbon. But if we follow these steps, we know that we are going to be half of the way there already. So conducting the LCA during the early design phase, identifying which materials are the largest carbon contributors. Again, designing for efficiency, just like for operational carbon, we have to design for efficiency with our envelope. Here we have to start looking for those optimization strategies around structure. Can we design a structure, alternative structure with mass timber, for example, or can we increase the column span so that we have less columns in our structure. Start to design with reused and salvaged materials. Start to design with materials that have a high recycled content and come regionally. Other materials that have low carbon, so finding low carbon design mixes or technologies or product alternatives, such as one example that comes to mind is like the interface carpet, which is a carbon positive carpet because they have all of the materials that are designed, offsetted too. Then you have, choosing material alternatives, designing with less carbon intensive materials. And then another key piece is designing for durability. How can we make our materials last? And one of the recommendations for that for our clients is like, instead of doing an interior refresh every 5 years, start to look at it in a longer term. So like every 15 years or 20 years, so that we can start to use not replenish those resources like every 5 years and save on that embodied carbon. And then designing for longevity of the building, so making sure that the structure remains intact for more than just 60 years. And then eventually, how can we plan for reuse and deconstruction early on in the design, so that when it comes to that phase, we already know what the plan is. So putting together that plan of action in place would be another critical component that architects and engineers and we all have to work towards. And with that, I'm going to pass it on again to Kalina to discuss some of our projects.
Sure. This will be a quick overview of just a few case studies, just touching on a few key points that we've actually implemented in practice to highlight some of the things we've talked about today. So on the screen now, we have the Robert Redford Conservancy. This is at part of Pitzer College. So this was a historic building. It was originally an infirmary building, I think from the Second World War. And so we wanted to not only maintain that historic architecture, but also hit some really high performance goals. So this is ILFI ZNE certified and also LEED Platinum certified. The maintaining all of the original structure there was part of an overall goal to minimize embodied carbon. And then operationally, we do have an all electric system. You can see we've optimized here for natural ventilation. So we have these operable windows on both sides. And where we do have large glazing, we've really taken advantage of the thermal mass of the building to get some of that storage benefit that we talked about. So you can see in the lower right-hand corner, we have exposed concrete slabs where it makes sense. To really sort of shift those loads so that we're not seeing peak heating when the sun is first hitting those spaces. And then offsetting all of that energy with PV arrays, incorporated some on the building, but because of the historic structure, it actually made more sense to build some shade structures out on the site as well to hit that ZNE target. Next one. So Kaiser Santa Rosa, this was a new construction site, but this was the first zero energy design medical office building. And so to meet some of the additional requirements for medical office space with air change rates, that had some additional challenges on its own. Another interesting point to this one was that it was a design build process. And so it was very budget driven, and we did have to make sure that all of these strategies fit within the prescribed budget. And so it was a very integrated process of making sure that where we were adding one thing, we were able to demonstrate the value and offset another. And one of the really good examples of that was the way we zoned our mechanical systems. So by having the individual envelope exposures or similar uses on a single system, we actually eliminated the need for reheat, which in a medical building where you have a lot of constant volume spaces, if you have to cool the air and then heat it back up again, that's actually really inefficient. So by eliminating the reheat, we eliminated the entire heating hot water hydronic system. And that was enough of a savings that we saved $1 million in first cost on the mechanical system, which paid for the entire PV array and allowed us to hit that net zero energy certification. So, I think when we talk about a lot of these high performance strategies, they often get dismissed as being not in the budget or saying, oh, well, that's a premium product, we can't do that here. And so I think this is a really good example of where when we really buckle down, we didn't use a crazy system here. It was still just packaged units on the roof, but the way we zoned it, we were able to eliminate some of that reheat, which is often just treated as a baseline assumption that of course you would have it. So it's really kind of challenging the way we design conventionally and doing it in a different way, and then taking advantage of those savings to be able to incorporate other elements that would often be seen as an add, like the on-site PV here. So the next one, J. Craig Venter. So again, this was another new construction project. This was the first zero energy designed lab in the world. And so this is another area where we often get told, oh, well, you could do high performance in Class A office, but I have a lab, you can't do that here. And so this is, again, one of those cases where we really wanted to challenge that mentality. So this is an all electric lab building. We designed this over 10 years ago now. So this isn't even, pushing the envelope now. We've been doing this for a long time, and it is demonstrating to work well. You can see it does have a large PV array. This does also incorporate some of that thermal storage we talked about. So there's two 25,000 gallon water tanks that were embedded under the parking garage below the building. So during the day when we're cooling, we take all that heat collected in the water and we push that warm water into these tanks. And then in the evening, because we're in San Diego, we tend to have warm days, cool nights. When we need that for heating, we pull that heat back out and use it to heat the building. So we're able to shift those loads back and forth during the day and offset the majority of those loads throughout the year. And then where we can't meet it just with that storage imbalance, we do have all electric heating and cooling systems to meet the needs for the space. We also did a lot of energy recovery on the air side. So where we're exhausting those high air flows from the labs, we recover that energy through some coils in that airstream as well. So again, thinking about keeping that energy and reusing it and harvesting it and storing it so that we're able to shift those loads to when we need them. Next one. So the Exploratorium project, this was in the Bay Area in San Francisco. Again, this was a reuse project. So we wanted to maintain the primary structure. This also was a historic building, and I'd like to point that out again because we often hear too where it's a historic building that we can't do these energy efficiency things because we can't touch the envelope or it's driven by one thing or another. And so this was, again, a historic remodel where we had some really good clear story windows. You can see that nice high bay space. So we took a lot of advantage of natural ventilation, being able to bring in cool air low and get it up high. We also added some fans in there to improve that. And displacement ventilation system. So when we are providing mechanical ventilation, we supply that air down low, we let it find the heat sources, and then as that heat warms the air, that warm air rises up away from the space. So that actually gives us really good air quality in the space because it's just passing through the occupied zone once, right? That displacement supplies low, mingles around with people, and then lifts itself up with the heat. So we get both good efficiency and also very good air quality. When we do need to do mechanical heating and cooling, when we can't meet it with the passive systems, this building actually ties into the bay water. So you can see where that building is located right on the bay. We actually use that bay as our heating and cooling source. So we pull the seawater up through some heat exchangers. It's only a very small temperature change. We move a lot of water, so there's very low thermal impact to the bay. And there was quite a bit of studies that had to be done to verify that we weren't going to have economic or ecological impacts from that. But we use that as essentially a source or a sink to be able to do the heating and the cooling for this building. Next one. So Horton Plaza, this is a project that we have going on right now here in San Diego. So it's just under 1 million square feet redevelopment in downtown San Diego. It was originally a shopping plaza, and it's being refreshed and redeveloped as a high-end office, life science, and then still some retail public space there in that Central Canyon area. This is seeking some pretty high performance targets. So we're targeting LEED Platinum, WELL Platinum. And then we're also targeting a really high performance from an embodied carbon standpoint. So one of the driving factors was that we wanted to maintain all of the primary structure. So you can see in the large photo on the left, that's a construction photo that I took a few weeks ago. We've kept all of the concrete slabs and all of the primary steel. So just in doing that, our carbon analysis showed that we were able to reduce the embodied carbon of this project by about 60 to 70% from if they had have just done a full demolition and rebuild, which was what a previous developer had actually planned for the site. So just that decision at the very beginning, like I said, just deciding that we're going to repurpose the existing structure was a 60 to 70% savings on that embodied carbon. And then so really what we're doing is we're reskinning it and we're adding high performance envelope to give us a lot of the benefit of of that thermal mass there. San Diego here, we have a pretty mild climate, so we certainly benefit from that. And then our heating and cooling system, it is all electric, features some heat recovery so that overnight when we're heating, we actually use the heat rejection from our baseload system. So our electrical rooms, our IT rooms, our chilled water system actually pulls that heat out, and then we use that as the heat source when we need to heat the building up in the morning. So again, using what we have on site and really recovering that heat rather than trying to generate it. We'll also be putting about a 2 megawatt PV array on top of this building, and we're putting in 2 Tesla power packs for battery storage to be able to control that load and harmonize with the grid as it continues to evolve. So those are a few projects that we have going on now, really putting into play some of these topics and ideas that Kanika and I talked about, and I'll let her kind of paint the picture for what's next.
So hopefully our presentation gives you an idea of why we need to look beyond net zero energy. Net zero energy is no longer the only goal that should be on projects. We need to go beyond and look at how can we incorporate this whole life carbon thinking to get to that decarbonized asset. And so Kalina talked a lot about grid stability, integration. We are seeing a lot more buildings moving towards in that direction, putting in infrastructure right now if that technology is not yet available at the utility scale, but then also looking at incorporating solar and storage in the building design, making sure there is infrastructure again for batteries and any other energy storage technology within the building design. I talked about embodied carbon, so doing that early analysis, looking at building throughout its life cycle, and then also thinking about the reuse and circular economy portion upfront when we start the building design is critical. And the big next thing is figuring out refrigerant management and how we are going to be doing that, especially as we start to electrify most of our systems that use refrigerants that are the most harmful to our environment. We did an IG Vision series at the beginning of the pandemic, and so these live stream events were recorded and are available on our website if you want to learn more about these topics. We have covered the embodied carbon and MEP design, and also deep dive into batteries and what that means in light of the electrification strategies that the projects should be implementing. And then we also put together the refrigerant and environmental impact best practice guide, and also the embodied carbon primer by Letty, which is one of the organizations that our colleagues in London are heavily involved with. And these are available to download for free on our website as well. So with those resources, I think we're going to end it here and then open it up for questions.
Well, thank you very much. What a great presentation. Really appreciate it. We have a couple of questions. Somebody said, with your experience in insulation, which low carbon insulation products do you recommend as far as having a carbon footprint?
So one of the best resources that I would recommend is EC3. So there are the baseline global warming potential targets specified in EC3, and you can basically look at what that insulation product for your particular region would look like. I can't, let me get back to you on that because I can't think of a product off the top of my head, but what we've been using the CLF baseline and the EC3 baseline to really look at embodied carbon, the environmental product declarations of products to identify where we can find those like good and better products.
Yes, maybe more generally, like comparing, say, fiberglass insulation to mineral wool insulation to Gutex wood fiber insulation. You guys have any kind of a feel for how those fall?
Definitely XPS is the worst of them all. Mm-hmm. So looking at mineral wool would be the way to move forward. Yeah, for sure. And so we also like try to minimize the XPS and EPS insulation in most of our projects when we work with clients. And I guess one thing I failed to mention was incorporating these performance specifications as we write these and making sure that the Division 1 specifications clearly spell out the sustainability goals is another thing that we can do to ensure that when the material procurement stage happens, it is already incorporated in the bid.
Okay, there's another question from Josh Luisi. In your case studies, were any cost analysis performed for dollars saved with on-site power generation / energy recovery?
Yeah, so I think it varies from project to project. I guess as an example, I can talk to you about what we did at Horton Plaza. So for Horton Plaza, there was originally a budget in the project to put in the PV array as capital expenditure as part of the construction budget. I think it was about a $6 million line item. What we ended up doing, we actually have a team at Integral Group that helps with solar procurement with development. So we actually helped the owner put together an RFP to procure a power purchase agreement, which is essentially where you get a solar developer, they'll come in, they'll install the panels on the roof and then be able to sell that power back to you. And so at an agreed rate. And so when we did that, we were able to remove that initial $6 million capital expenditure. And then the power purchase agreement over a 20-year term, I think came in at about 60% less than utility scale rates, particularly when we incorporated that battery storage, because with the battery storage, we were able to recommend one of the SDG&E rate structures that would sell energy quite cheaply most of the time, but charge a lot at those peak times. And because we had the on-site storage, we didn't have to worry about those critical peak periods and really get to take an advantage of the lower rates. So using kind of a few different avenues, both the power purchase agreement and then also the storage, which let us use a different rate structure, it ended up being quite actually a good savings to the project.
Extremely creative, but not very scalable to a residence. Yeah.
Right. Harder to do at the residential scale. So that's something that was specific to that large commercial scale.
Thanks for that.
Sorry,
There's another question about spray foam insulation versus rigid insulation. Any comments on either one of those options having less of a carbon impact, I suppose would be the way to frame the question.
There is a great resource that I can circulate after, which basically compares all of the different insulation options that are available out there in the market. I believe it is also by an Architecture 2030 partner organization. And so any kind of rigid insulation would be considered a worst case than a spray foam insulation. But then I guess to add a layer of complexity on top of that would be to consider the health impacts associated with the spray foam insulation as well. So again, like there is no resource currently in the market which can compare products against all of these different considerations. But for us, like depending on what the focus of the project is, for us to be considering whether embodied carbon or health and wellness, we have to find that happy medium in between. And so that's why I feel like mineral wool would be one of the better ones to go for.
Great. If you could send that to Tara, she'll get that out to all of us.
Yeah, definitely.
Also, there's a question about, we claim that we're the first city to adopt the 2030 standard on our building code back in 2008. They said all residential buildings have to do a 50% increase over Title 24 to meet the 50% energy reduction. And I didn't know if you knew of anybody else who came in front of us. That's a question from Ed DeVicente. It was for all projects, not just municipal projects. A lot of cities adopted stuff prior to 2008 that said all city projects have to meet the 2030 commitment. But it's not really your area of expertise.
Yep.
So.
I'll take your word for it.
All right, with that, I think our time is up. And man, what an excellent presentation. Thanks so much for sharing all of your knowledge. And people who want to get inspired, go to the Integral website and just see what these guys are doing. It's really, really incredible. I think we need to tap you guys for some more presentations, because just the whole thing about cooling something and storing that heat in water, or heating something and storing the cool in water somewhere, and then transferring that heat or cool to a spot where you need it a little bit later, is just mind-blowing, Kalina. And I'm sure it's like a battery, but for heat, right?
Exactly.
And I can't imagine how how those things go. Maybe we'll do a field trip down to Horton Plaza after you get some of that stuff installed, so we go down there and check it out. It's incredible. And thank you so much for sharing your expertise, your knowledge, your projects. What a great time. Really appreciate it.
Thank you
Great.
so much.
Thank you.
This is
Yeah.
great.
Thank you.
Bye, everyone.
Okay, see you guys later.